Welcome to the Modal section of our course. I'm Alona. I'm a data engineer and developer relations at DLT Hub. And in this section, I will share with you how to marry DLT and Modal to orchestrate your data pipelines. Before we get started, let's quickly check the prerequisites of this section. You'll need a local environment set up, basically Python, ready to go on your machine. And you will also need a Google Cloud Platform account since we will be using BigQuery as a destination. And finally, a GitHub account because we will be pulling data from GitHub API during the exercises. With these three things in place, you will be ready to follow along smoothly. If you haven't watched the introduction and case study sections yet, please go back to them first. In the case study, Ashish walks through a DLT pipeline that we will be deploying together here. We will start simple, then build step by step from understanding what Modal is to deploying, scaling, and finally handling more advanced patterns like backfilling and incremental loading or parallel runs. Now let's take a look at the agenda. Before we jump into the details, let me give you a quick roadmap of what this section will look like. The goal here is not just to show you Modal, but to help you understand how it fits together with DLT for real data pipelines. We will start with what Modal is and why it's special, then move into a short introduction to serverless orchestration. Next, we will do something practical, create a Modal trial account together. After that, I will show you how to package and deploy a DLT pipeline with Modal. Once we have it running, we will look at how to trigger and scale pipeline. Then we will dive into incremental loading and backfilling, two very common challenges in data engineering. And finally, we will explore parallelizing pipeline runs, so you can see how Modal handles workloads at scale. By the end of this section, you will not only know how Modal works, but also how to use it with DLT for real-world pipelines. Let's start with a simple question. If you want to run your data pipeline today, what do you need? Usually you'd set up a server, install Python, manage packages, maybe Docker, maybe Kubernetes, definitely some cloud account. And once it's running, you also need to keep it running. That's a lot of work for something that should feel simple. Now imagine instead you just write your Python code, push it somewhere, and it runs in the cloud instantly. No servers, no maintenance, no works on my machine problems. That's Modal. So what exactly is Modal? Modal is a serverless platform built for developers. That means you can run and deploy your Python code in the cloud without worrying about servers, Docker, Kubernetes. Modal takes care of all that behind the scenes. It's not just about running small scripts. With Modal, you can handle heavy tasks like training generative models, running large-scale batch jobs, or managing job queues. And the best part is that it scales up or down automatically. So you don't waste time or money on infrastructure. In short, you focus on your code. Modal makes it run anywhere in the cloud. So why do people get excited about Modal? First, it's developer first. It's built with Python developers in mind. You can write code on your laptop and deploy it to the cloud in seconds. Second, it gives you instant scaling. Modal can go from 0 to thousands of CPUs or GPUs automatically. No need to set up clusters, tune configs, or manage nodes. Third, it's an all-in-one platform. It comes with everything you usually need: functions, schedules, secrets management, parallel execution, all included out of the box. And finally, it's really a new serverless standard. It's a modern alternative to the heavy infrastructure we usually associate with data or machine learning workloads. How does it work? Modal takes your code, puts it in a container, and executes it in the cloud. So that's it. Where does Modal actually run your code? The answer is simple. It runs in Modal's own cloud environment. That's the magic. They take care of all hard infrastructure for you. So you don't have to touch Kubernetes or Docker or even set up an AWS account. Right now, Modal is Python only, which makes it especially nice for us. But they may support other languages in the future. Let's talk about costs, because that's often the first question when it comes to running pipelines in the cloud. Here's an example. Imagine we run a DLT pipeline for 4 hours every day on Modal. The setup would be pretty light. 1 gigabyte of RAM and 5 gigabyte of disk space. For compute, we can choose between a fraction of a CPU or a full core. Now the numbers. Memory costs about 3 cents a day. A minimal CPU share costs 2 cents a day. A full CPU core costs about 19 cents a day. So in total, running on a fraction of a core would be about 6 cents a day, or around $2 per month. And with one full core, it's still only 22 cents a day, or around $7 per month. That means you can run a daily production pipeline for the price of a cup of coffee. Before we dive into orchestration with Modal, let's quickly recall what it normally looks like. Traditionally, if you want to run an orchestrator, you need a server. That could be a physical machine or virtual machine on GCP or an EC2 instance on AWS. What does that mean for you? You have to set it up, install and configure everything. You need to monitor, patch, and keep it secure. You must scale it manually when your workloads grow, and it's always on, which means you pay for uptime, even when it's unused. So in the old world, orchestration is tied to infrastructure you have to manage. In the serverless world, we will see how all of that disappeared. So what does serverless mean in this context? A serverless orchestrator removes the need to provision or manage machines yourself. Instead, you don't deal with servers, virtual machines, or containers at all. The orchestrator runs as a fully managed service. It spins up the compute only when your workflow is triggered. Each task in your workflow is usually a cloud function, a piece of Python or other language code that executes in an isolated runtime, then shuts down after finishing. Resources like memory and CPU are allocated on demand and scale automatically. And you only pay for the execution time and resources consumed, not for machines sitting around unused. Common examples are AWS Step Functions, Google Cloud Workflows, and Azure Durable Functions, and Modal. Now let's bring this closer to our world. Why is serverless orchestration so useful for ELT pipelines? First, it's scalable. Your pipeline can be tiny, pulling just a few rows, or huge, processing terabytes of data. Serverless adapts automatically without you tuning machines. Second is cheaper. Since ELT pipelines usually don't run all the time, there's no reason to pay for always-on servers. With serverless, you only pay for the work that actually gets done. Third, it means less ops work. Students, startups, or small teams don't need a DevOps engineer to babysit servers or set up infrastructure. You can just focus on your pipeline logic. And finally, it's cloud native. It integrates easily with cloud storage, databases, and APIs, which is exactly where most of our data already lives. So with serverless, pipeline becomes simpler, cheaper, and much easier to scale.